Good afternoon, everyone. My name is Hillary Cohen, Communications Manager for the U.S. Chemical Safety and Hazard Investigation Board. Welcome to our third quarter public business meeting. Today, we will discuss ongoing investigations, recommendations update, and play our latest safety video. Following our formal presentation, we will have a comment period. Please note that you will need to unmute your line on your end when your username is called in order to make your public comment. If you have any technical issues, please email public@csb.gov and we'll try to help you out during the meeting. I would now like to introduce our chairperson, Steve Owens, who will run today's event.
Well, thank you, Hillary, and hello, everyone. Thank you for joining us today. As Hillary said, I'm Steve Owens. I'm the chairperson of the Chemical Safety Board. The CSB has been incredibly busy since our last public meeting in January. Just last month, on March 13th, we issued the final report for our investigation into the November 2023 fire at the Marathon Martinez Renewables facility in Martinez, California. The incident seriously injured one employee who suffered third-degree burns over 80% of his face and body and resulted in approximately $350 million in property damage to the facility. You'll hear about our report on that investigation a little bit later in this meeting. The Marathon Martinez report is the 19th report that we've issued under the CSB's new leadership since July of 2022. As you may recall, when Sylvia Johnson and I joined the board in February of 2022, the CSB had an enormous and unacceptable backlog of 17 open investigations that had accumulated under the years of prior agency leadership, with some dating as far back as 2016. I became the interim executive of the CSB in late 2022 after the former chairperson resigned and left the agency. I was confirmed by the Senate to be the new CSB chair a few months later. Kathy Sandoval was also confirmed to be a board member at that time and joined the CSB in February of 2023. Everyone at the CSB has been working together as a team, and from late July 2022 until late December 2023, we issued final reports for all 17 of those open investigations and completely eliminated the backlog. As I said at our last meeting, those 17 reports are the most reports that the agency has ever issued in such a short period, and they represent the CSB's highest level of efficiency and productivity in the agency's history. On top of that, in June last year, we issued an additional final investigation report, which was not part of the backlog. This was for our investigation of the September 2022 fatal fire at the BP Husky refinery in Ohio, which resulted in the death of 2 employees who were brothers. That was the 18th report issued by the CSB between July 2022 and June 2024, the most reports ever issued by the CSB in a 2-year period, again reflecting the agency's high level of efficiency and productivity. As I noted at the beginning of our meeting, with the publication of the BP Husky and Marathon Martinez reports, we now have completed 19 investigations during the time that Sylvia Johnson, Kathy Sandoval, and I have been leading the agency. It's been an extremely important and incredibly efficient and productive period for the agency. The CSB has 8 current investigations underway. That's one of the largest number of current investigations in many years. We recently issued updates on 2 of our current investigations. One is the fatal release of hydrogen sulfide at the Pemex petroleum refinery in Deer Park, Texas, which occurred on October 10 last year. 2 contract workers died as a result of the release, 35 people were injured and treated at the scene, and an additional 13 workers were transported to local medical facilities. The release also prompted a shelter-in-place for 2 neighboring cities. The other is the fatal explosion of the Givaudan facility in Louisville, Kentucky, which occurred in November of last year. 2 employees were killed, and a number of others were taken to local hospitals. The blast also damaged a number of homes and businesses in the area. Debris from the explosion, including large sections of process equipment, was ejected into the nearby neighborhood, some as far as 400 feet away from the facility. Local officials also issued a shelter-in-place order for a 1-mile radius around the facility. You'll hear a presentation about those 2 updates during this meeting as well. The CSB has also been very busy with some other very important efforts since our last meeting. Last month, the CSB marked the 20th anniversary of the fatal explosions and fire at the BP Texas City refinery in Texas City, Texas, that occurred on March 23, 2005. The incident resulted in the deaths of 15 people and injuries to 180 others. To remember this tragic event, the CSB released a new safety report called an Investigation Digest. The digest summarizes the recommendations made by the CSB as a result of the BP Texas City investigation and some of the steps that have been taken by the chemical industry since 2005 to improve safety at refineries and other chemical facilities. The BP Texas City disaster is one of the worst industrial accidents in recent U.S. history and one of the most serious incidents ever investigated by the CSB. As a result of the CSB's investigation and recommendations, a number of important steps have been taken to improve practices at refineries and other chemical facilities. But more still needs to be done to improve safety at these facilities. And the CSB is committed to ensuring that a catastrophe like BP Texas City never happens again. In February, we released a new safety video on our investigation into the January 2020 fatal propylene release and explosion at the Watson grinding facility in Houston, Texas. A massive explosion resulted in the deaths of 3 people, 2 workers and a nearby resident, and damaged hundreds of neighboring homes. We'll show that video to you later in this meeting too, just in case you haven't seen it yet. Finally, in addition to all the other things that we've got going on, we have continued to expand upon our commitment to transparency and information sharing. As you know, since July 2022, the CSB has been making basic data on incidents that have been reported to the agency under our accidental release reporting tool. In January, we launched a new initiative to give the public more details about the serious incidents that have been reported to the agency under that rule. The CSB is compiling summaries of those incidents, which will be made available to the public on a regular basis. Since the reporting rule went into effect 5 years ago, the CSB has received reports of nearly 500 serious chemical incidents in 43 states. The CSB released Volume 1 of the incident reports on January 14th of this year, and we released Volume 2 last month on March the 12th. Combined, the 2 volumes of reports cover 51 serious chemical incidents in 22 states involving 12 fatalities, 40 serious injuries, and over $1.7 billion in property damage. The CSB is working on Volume 3 and will continue to make these reports available to the public on a regular basis. You'll be hearing more about the Volume 2 reports later in this meeting as well. Over the years since the CSB became operative in January of 1998, the agency has deployed to nearly 180 serious chemical incidents that have involved more than 200 facilities, 200 fatalities, over 300 injuries, and many billions of dollars in damages to chemical facilities in nearby communities. I'm sorry, I should correct myself. It's over 1,300 injuries and many billions of dollars in damage to chemical facilities in nearby communities throughout this country. In fact, the 19 investigations alone for which the CSB has issued final reports since January 2022 under the agency's current leadership involved 26 deaths, 107 serious injuries, and over $3 billion in damage to chemical facilities and the surrounding communities. If the CSB's investigations and recommendations prevent at least one catastrophic incident, the costs avoided from damage to facilities in nearby homes and businesses, legal settlements, personal injuries, and the loss of life far outweigh this agency's annual budget, which presently is only $14.4 million. Although the CSB has a very limited budget and a very small number of employees, this agency has made substantial progress in recent years. I believe that it's fair to say that the CSB has now become one of the most productive and efficient agencies in the federal government. Before I turn the floor over to my fellow board members for their remarks, I want to just reiterate what Hillary Cohen said and remind everybody that at the end of today's presentations, we'll provide an opportunity for public comments. In the interest of time, we ask that you please keep your comments to 3 minutes. Please use the icon on your screen to raise your hand so that you can be recognized to speak. If you'd prefer to submit written comments, as Hillary said, you can send them to public@csb.gov. That's public, PUBLIC, at csb.gov. Now I'd like to turn this over to Sylvia Johnson for her remarks, and then the board member Kathy Sandoval as well. So Sylvia, please go ahead, and then Kathy, please do so as well when Sylvia is concluded. And again, I want to thank you all very much for being with us here today. Sylvia.
Thank you, Steve, and hello, everyone, and welcome to today's meeting. As I begin, I want to first acknowledge the extraordinary work of the CSB staff since our last meeting. This team continues to demonstrate an unwavering commitment to public safety, and today I'm proud to highlight some of the safety products and initiatives we've advanced since January of this year. As the chairperson said, we issued the final report on the heater tube rupture and fire at the Marathon Martinez Renewables facility in California. You will also hear presentations on the hydrogen sulfide release at the Pemex Deer Park refinery in Deer Park, Texas, that resulted in 2 fatalities and 13 injuries, as well as an update on the Givaudan Sense Color facility in Louisville, Kentucky, that fatally injured 2 employees and injured 11 others. As the chairperson said, we've released the first 2 volumes of the accidental release reporting rule, and I would remind everyone here that these are incidents that we were unable to deploy to due to our limited resources, but they are important and important learning lessons nonetheless. In addition to other products we put out since our last meeting, as Steve mentioned, the CSB published the 20th anniversary investigation digest of the BP Texas City disaster. And this report reaffirms our longstanding role in driving chemical safety and improvements. There were 26 recommendations issued in that historic investigation, and 25 have now been successfully closed. The CSB continues to issue important safety recommendations, and you will hear an update on our latest recommendation status changes later in today's meeting. The work of the CSB is not just data collection, but it is really a call to action. Each of our investigations carries consequences for either a worker, a company, a family, a community, and/or the public. The work of the CSB demands that we do more to prevent future tragedies. Finally, since our last meeting, the CSB released another one of our highly regarded safety videos. This one focuses on the devastating propylene release and explosion at the Watson grinding facility in Houston, Texas. Our videos remain one of our most accessible tools for public education and industry reform. The public deserves transparency, and the CSB products provide a clear-eyed view of the scale and cost of preventable chemical incidents in this country. We're not just investigating incidents, we're championing a culture of prevention and protection to protect workers, communities, and the environment. Engaging stakeholders remains a cornerstone of our work as well. Just a few weeks ago, Executive Director Kleist and the board participated in a webinar hosted by the New Jersey Environment Works Council. And in addition to providing an update on several CSB investigations, the board discussed the CSB's role in preventing chemical disasters, the importance of our recommendations, and the role of union workers in CSB investigations. Looking ahead, we will once again mark an important national moment for workers. On April 28th, we observe Workers' Memorial Day, a solemn day of remembrance for those who have lost their lives on the job. It's been nearly 40 years since the first observance, and while we've made considerable progress, our work is far from finished. So we want to honor the fallen, not just in words, but in action by recommitting ourselves to making every workplace safer and stronger. I look forward to today's meeting and thank you for your continued commitment to the vital mission of the CSB. And with that, I will now turn it over to you, Kathy.
Well, thank you, Sylvia, Dr. Johnson. Appreciate your remarks and welcome everyone to the CSB's quarterly board meeting. And I'd also like to add thanks to the CSB staff for their dedicated and hard work on a variety of initiatives and investigations that have been ongoing. So we really appreciate your dedication, and it makes a huge difference. Our chairperson gave really some terrific statistics and important information that really sums up the CSB's work particularly over the last 3 years, but also over the decades of the CSB's existence. And I think what it really underscores is the value add of the CSB. And this is actually exemplified in our report on the Marathon Martinez incident. In that incident, an individual, Jerome Serrano, was terribly injured, and Mr. Serrano is mentioned in the report. And one of the things that was highlighted was the practice of putting people right next to operating industrial heaters to make adjustments while fluid is still flowing is an incredibly dangerous practice. And the CSB has the ability to do cross-analysis of hazards because of our data reporting and our ability to investigate incidents. And this is one of the things that was highlighted as well in our incident reports, volume 1 and 2, where we looked at other incidents for which the CSB was unable to do a full deployment. So that cross-analysis is something that really the CSB uniquely brings that hasn't been brought either by other agencies or even by the independent analysis that one company might do. The other, I would actually argue, both safety advantage and in fact competitive advantage of the CSB is that it really helps to enhance our national safety culture. And I would actually argue that a nation's safety culture is a competitive advantage as well as a moral imperative. That maintaining the safety of workers, of communities, of neighboring businesses, the environment, of critical infrastructure itself is absolutely critical to a nation's ability to compete, as well as to a company's ability to compete. And one of the things that the CSB does that I think is also tremendously beneficial is that an important component of safety culture is what we call knowledge management. And one of the most important parts of knowledge management is sharing knowledge and information. And that's what the CSB seeks to do through its reports, where we investigate and then share analysis about the root causes of these incidents that then could help other companies to prevent these incidents from the design phase through the operational phase, through thinking about their supply chain and all phases. That knowledge sharing can also help students and teachers and our future engineers to think about what we need to do to really build in safety, so that we build in that safety culture and we build in that competitive advantage for generations to come. So that information sharing is so important. And the CSB does it well, and I'd like to also commend our video department. The CSB videos won the Silver Button Award from YouTube, recognizing the number of people who have watched our videos. And I think that the video program, as well as our reports, really have made a tremendous contribution to safety. And each and every one of us is very proud to be part of this team. So with that, I'll give it back to you, Steve Owens, our chair, and we'll hear more about our investigations and updates. So thank you.
Well, thank you, Sylvia, and thank you, Kathy, for those great remarks. I appreciate so much all the hard work that each of you are doing on this board, as well as along with all of our terrific career professional staff, one of whom the folks in this meeting are just about to hear from. And I'd like to now turn the program over to Steve Kleist, who's the CSB's Executive Director of Investigations and Recommendations. So, Steve?
Great. Steve, thank you very much, and good afternoon to everyone. This afternoon, we have 11 presentations that highlight the accomplishments for the Office of Investigation since our last business meeting. We're going to start off with a presentation from the investigator in charge of the Marathon Martinez Renewables Fuels investigation, Melike Yarsis. Melike, please proceed with your presentation.
Thank you, Executive Director Kleist. My name's Melike Yarstes, and I'm the investigator in charge for the CSB's investigation into the fired heater tube rupture and fire at the Marathon Martinez Renewables facility. Next slide, please. On November 19th, 2023, at 12:21 a.m., a metal tube ruptured within a fired heater during the initial startup of a renewable diesel hydroprocessing unit at the Marathon Martinez Renewables facility in Martinez, California. The ruptured tube released renewable diesel and hydrogen, resulting in a fire that seriously injured one Marathon Martinez employee. The incident occurred while the unit was starting up for the first time as a renewable diesel hydroprocessing unit. Next slide, please. Leading up to the tube rupture, a manual valve upstream of the heater was open when it should have been closed, causing a significant amount of process flow to divert around the heater. The flow diversion occurred downstream of a safety instrumented system flow meter that continued to indicate adequate flow to the heater. Concurrently, the air supply to some of the heater's in-service burners was blocked while the heater was operating, which caused high temperatures in the convection or upper section of the heater, a process condition called afterburning. There was insufficient flame detection and combustibles monitoring capability to detect afterburning conditions inside the heater. Without this information, Marathon Martinez facility personnel were unaware of the flow diversion or afterburning. Next slide, please. The significant reduction in process flow through the fired heater, combined with afterburning in the convection section, caused the heater's convection section tubes to overheat well above their design temperature, bulge, and lose their strength, a damage mechanism called short-term overheating. In an effort to reduce the tube metal temperatures, Marathon Martinez facility personnel directed a field operator to turn off some of the heater's burners, an operation that placed the field operator immediately next to the fired heater, rather than shutting down the heater remotely from the control room. While the field operator was standing near the burner controls, one of the overheated tubes weakened to the point that it could no longer contain the process pressure and ruptured, releasing renewable diesel and hydrogen into the fired heater. The flammable mixture ignited and escaped from the heater, engulfing the heater in flames. The field operator was seriously injured by the fire. Next slide, please. The CSB determined that the cause of the incident was overheating of the fired heater's tubes because a misaligned or open valve diverted a significant amount of process flow away from the heater, and 2 of the 4 burners were operating with cover plates blocking their air inlets, leading to afterburning in the convection section. Next slide, please. Contributing to the severity of the incident was the presence of a field operator next to the fired heater when the tube ruptured, because personnel directed the field operator to conduct troubleshooting actions in close proximity to the fired heater while the heater was in an unsafe condition at high tube temperatures, and Marathon had not established effective not-to-exceed limits or safe operating limits for the fired heater tube temperatures to indicate when the fired heater was in an unsafe condition, which resulted in personnel continuing to troubleshoot high tube metal temperatures until the tube ruptured instead of shutting down the fired heater remotely from the control room. Next slide, please. Marathon Martinez's failure to identify the potential for the flow diversion that defeated the heater's safety interlock system and inadequate engineering and administrative controls to prevent the valve misalignment contributed to the incident. Marathon Martinez's inadequate operating procedures and operator training for safe burner operation and inadequate engineering controls for operators to identify combustion issues inside the fired heater also contributed to the incident. Marathon's inadequate oversight of the Martinez facility's conformance to company standards allowed these deficiencies that contributed to this incident. Next slide, please. The CSB identified 6 safety issues, which we will review briefly in the following slides. Next slide, please. The first safety issue is safe operating limits. Safe operating limits are process parameters that, if exceeded, could cause a significant process safety incident unless immediate action is taken to bring the process to a safe state. On the day of the incident, the fired heater's tube metal temperatures rose to more than 1700 degrees Fahrenheit, far exceeding the 1120 degrees Fahrenheit design tube metal temperature. Marathon had not equipped the fired heater at the Martinez facility with adequate safe operating limits, which the company called not to exceed limits, and their associated alarms to alert personnel that the tube metal temperatures had exceeded their mechanical design limits and that the fired heater was in an unsafe state. As a result, Marathon Martinez facility personnel continued to troubleshoot high tube metal temperatures instead of evacuating personnel and remotely shutting down the heater. This put an operator in an unsafe location when the fire erupted. Next slide, please. The field operator was at risk when the fired heater tube ruptured because he was standing directly next to the heater in order to turn off individual burners during the troubleshooting activities. The CSB found that the Marathon Martinez tube rupture incident is not an isolated event in the industry. From 2020 through 2024, the CSB has received reports of at least 8 fired heater tube rupture incidents at several companies that resulted in accidental releases of regulated or extremely hazardous substances that meet the CSB's reporting criteria. Despite the frequency and severity of these hazardous tube rupture events, neither Marathon's corporate standards nor recommended engineering controls and practices issued by the American Petroleum Institute, API, adequately prevent workers from being in close proximity to fired heaters while tube temperatures are dangerously high, such as by requiring for troubleshooting to stop at certain conditions and to remove personnel from the vicinity of the fired heater. Next slide, please. The next safety issue is the low flow through the fired heater. The Marathon Martinez fired heater was equipped with a safety instrumented system that was intended to automatically shut down all burners upon detecting low process flow to the heater. The safety instrumented system's flow meter did not detect the low flow to the fired heater, however, because the process material was diverted through piping that was downstream of the flow meter, which led to the incident. Marathon had not identified the potential flow diversion either in process hazard analyses, or PHAs, or when specifically looking for flow diversions around fired heaters after a similar 2018 incident at another Marathon refinery, which you can read about in our report. Next slide, please. Next, we talk about burner operation. During the hour before the tube rupture, 2 of the 4 burners in service were operating with cover plates that blocked airflow into the burners, which likely prevented proper air-fuel mixing at the burners. Without proper air-fuel mixing, some unburned fuel likely moved upward in the fired heater, where it subsequently came into contact with the available air at or near the convection section and ignited, causing afterburning and high tube temperatures until a tube overheated and ruptured. Marathon had not adequately implemented operating procedures or operator training to ensure that cover plates were to be removed before lighting burners. Furthermore, Marathon had not equipped the heater. Next slide, please. There, that's, oh, no, yes, that one, thank you. Marathon had not equipped the heater at the Martinez facility with adequate combustion safeguards that could have alerted operations personnel to the afterburning taking place in the fired heater. such as an effective burner flame detection system or combustibles monitoring available to board operators in the control room. The CSB found that there is currently inadequate industry guidance for fired heater safeguards. At the time of the incident, Marathon's internal standards exceeded API guidance. Had the API's guidance defined a minimum safety requirement for adequate flame detection or combustibles monitoring available to the control room, it could have driven Marathon to install a more robust combustion monitoring and protection system that could have protected the fired heater from the afterburning that contributed to the incident. Next slide, please. Leading up to the incident, a valve was open when it should have been closed, allowing process material to bypass the fired heater and contribute to the tube overheat and rupture. Marathon had not used effective operator training, equipment labeling and operating procedures, inherently safer design, or walk-the-line practices, and industry framework to minimize valve alignment errors to help ensure that valves were correctly aligned during startup activities. Next slide, please. Finally, we discuss corporate oversight. When Marathon Petroleum Corporation acquired the Martinez facility in 2018, the facility operated as a petroleum refinery. In 2020, the facility idled its refining operations, operated as a terminal for about 3 years, and restarted as a renewable diesel facility in 2023. Marathon did not adequately ensure that the Martinez facility met the company's minimum safety expectations before it started up as a renewable diesel facility. As a result, the Martinez facility lagged behind in conforming to Marathon's corporate standards, leading to deficiencies in local policies and their implementation that contributed to the November 19, 2023 incident. Next slide, please. The CSB made a total of 8 recommendations as a result of this investigation. Most of the recommendations are addressed to the Marathon Martinez facility and Marathon Petroleum Corporation to prevent similar incidents at all of the company's refineries. Additionally, the CSB made a recommendation to the American Petroleum Institute, API, to revise its standard on instrumentation, control, and protective systems for gas-fired heaters, with the following 3 types of requirements. First, requirements for proper response to high tube metal temperatures, including guidance to alert operators when safe operating limits are exceeded, and to specify predetermined response actions, such as shutting down the fired heater remotely. The predetermined response actions must include actions that specify when to stop troubleshooting and remove personnel from the vicinity of the fired heater. Second, design requirements for protecting fired heaters from low process flow, where process piping diverges downstream of a flow meter. Requirements may include achieving proof of flow to the heater and the use of interlocks to prevent backflow, reverse flow, or other diverted flow scenarios that could defeat the safety instrumented system. And last but not least, engineering safeguard requirements to detect and prevent afterburning in fired heaters. These requirements may include the use of instrumentation. The requirements shall address monitoring capability from the control room. Next slide, please. This concludes my presentation. Thank you.
Well, Melike, thank you very much for your hard work in developing such a high-quality report and bringing this investigation to its successful closure. We very much appreciate that. The next presentation will focus on the second Pemex investigation update that was published on March the 17th. The investigator in charge, Tyler Nelson, will be providing us with the overview of that second investigation update. Tyler, please proceed.
Thank you, Executive Director Kleist. My name is Tyler Nelson, and I'm the investigator in charge of the CSB's investigation of the Pemex Deer Park fatal hydrogen sulfide release. Today, I'll be providing an update on the CSB's investigation of this incident. On October 10th, 2024, at 4:23 p.m., approximately 27,000 pounds of hydrogen sulfide gas were released during a maintenance activity at the Pemex Deer Park refinery in Deer Park, Texas. The release fatally injured 2 contract workers. The CSB released investigation updates in November 2024 and March 2025. You can find the published updates and related news releases on our website, csb.gov. On the morning of October 10th, a Pemex operator issued a work permit to REPCON to remove 15 piping isolation devices called blinds in amine regeneration unit number 6. The last 2 blinds were located on piping segments containing acid gas, a gaseous mixture made of highly toxic hydrogen sulfide and carbon dioxide. The permit required the workers to wear supplied air respirators at the final 2 blind locations. A Pemex operator gave the REPCON foreman a drawing and a list of the 15 blinds and walked him through the units to show him the location of the blinds. During their walkthrough, the Pemex operator made sure that the first 13 blind locations had been depressurized. However, they did not visit the last 2 blind locations because the Pemex operator expected to be present later when those flanges were opened. One of these blind locations, called blind 407, was about 25 feet above the ground. Rather than climbing to view this location, the operator and foreman viewed it from the ground underneath. The REPCON foreman gathered 4 Boilermakers to remove the blinds, who had all been working in the nearby sulfur recovery unit. Unlike the amine regeneration units, which were partially operational and undergoing maintenance, the sulfur recovery unit was completely shut down for a planned outage called a turnaround. The REPCON foreman gave the Boilermakers the work permit and showed them the blind locations. The Boilermakers split into pairs and spent the day removing the first 13 blinds. They did not have the drawing or the blind list, so they used visual indicators to determine where the blinds were located. They looked for orange and blue blind identification tags and red flange locking devices. The tags and locking devices were common and required in the turnaround at the sulfur recovery unit where the Boilermakers had been working, but were not required for maintenance activities occurring in the amine regeneration units where they were on the day of the incident. However, Pemex operators had previously hung blind tags in the amine regeneration units. Around 3:30 p.m., the Boilermakers had finished removing the first 13 blinds. They checked out supplied air respirators and emergency escape compressed air cylinders and put on the equipment. They climbed to a platform to work on blind 407 and connected their respirators to air hoses. When they arrived at the platform, they saw 2 identical piping segments located 5 feet apart. One was blind 407 on amine regeneration unit number 6, the intended location of the work. The other was on an active pressurized pipe containing acid gas from amine regeneration unit number 7. They did not see an orange and blue blind identification tag on either of the flanges, but they did find a red flange locking device on or near the amine regeneration unit number 7 flange. So they concluded that this flange was the intended location of the work. After the incident, the CSB found a blind identification tag on the railing of the platform above where they were working, away from their line of sight. Believing that they were working on blind 407, they began removing bolts on the amine regeneration unit number 7 flange. About 100 feet away, at 4:22 p.m., portable gas monitors in the sulfur recovery unit detected hydrogen sulfide and alerted contractors who attempted to notify Pemex operators with their handheld radios. Since the Boilermakers were in full-face supplied air respirators, they may have been unaware of the leak, so they continued to remove bolts. At 4:23 p.m., the flange opened and forcibly released toxic hydrogen sulfide gas. The Boilermakers disconnected their supplied air hoses to flee from the release. One Boilermaker engaged the valve on his emergency escape cylinder and safely fled from the scene. The other Boilermaker collapsed near the ladder several feet away. He was found by emergency responders on the platform with his respirator mask off and lying next to him, fatally injured from hydrogen sulfide poisoning. The wind carried the hydrogen sulfide into the nearby sulfur recovery unit, where portable alarms activated. Pemex operators put on self-contained breathing apparatuses and ran to the amine regeneration units to investigate the release. The amine unit alarms did not activate until at least 4 minutes after the release began. 2 contract workers from another company were working on equipment 250 feet away and downwind from the release. One of these workers was also fatally injured. Other contractors working in the sulfur recovery unit heard alarms and evacuated to the primary assembly point, which was located upwind towards the direction of the release. 47 contractors from 10 companies were evaluated for hydrogen sulfide poisoning, and 13 additional contractors were taken to nearby medical facilities. Between 4:26 and 4:34 p.m., emergency responders arrived and assisted operators with isolating the leak. The site-wide alarm was sounded at 4:35 p.m., 12 minutes after the release began. At 5:22 p.m., nearly an hour after the release began, emergency responders reassembled the leaking flange, stopping the release. In total, this incident resulted in 2 fatalities, the release of more than 27,000 pounds of hydrogen sulfide to the environment, and property damage from loss of use of $12.3 million. The CSB's investigation is ongoing, and we're continuing to gather facts and analyze key areas, including Pemex's safe work practices, human factors considerations, turnaround and maintenance policies, emergency preparedness, respiratory protection, and remote isolation capabilities. This concludes the update on the CSB's Pemex Deer Park investigation. Thank you.
Thank you, Tyler, for your work in this investigation. Our next presentation will be on the investigation update that was published on February 27th in connection with the Givaudan Sense Color investigation. The investigator in charge, Lauren Grimm, will be making the presentation this afternoon. Lauren, please proceed.
Thank you, Executive Director Kleist. My name is Lauren Grimm, and I'm the lead investigator of the Givaudan Sense Color incident investigation. I will be presenting preliminary information that our team has gathered on this incident. Next slide, there we go. On November 12th, 2024, a batch reactor vessel exploded at the Givaudan facility in Louisville, Kentucky, while it was producing caramel coloring for a food product. The explosion fatally injured 2 employees, and 3 additional employees were seriously injured. The explosion caused equipment and debris to propel outside of the facility fence line and resulted in substantial property damage to the facility, as well as nearby homes and businesses. Local officials issued a shelter-in-place order for a 1-mile radius around the facility. The facility has since ceased its operations, and it's now being demolished. The Givaudan group of companies manufactures ingredients for food and beauty products and is headquartered in Switzerland, with facilities located around the world. The Givaudan facility in Louisville, Kentucky, produced caramel coloring for food and beverages and employed about 55 people. D.D. Williamson, which is a fully owned subsidiary of Givaudan, operated the facility in Louisville. D.D. Williamson began producing caramel coloring at the facility in 1948, and it was acquired by Givaudan in December of 2021. The Givaudan facility operated in close proximity to residential properties and other businesses. The nearest residential property is located less than 100 feet from the facility. The Givaudan facility operated 6 different batch reactors inside its manufacturing building to produce the caramel coloring. On November 12th, 2024, Givaudan was producing caramel coloring in its batch reactor number 6. A simplified schematic of the top portion of batch reactor 6 is shown here in this figure. Batch reactor 6 was equipped with a vent valve that could automatically open and close to control the batch reactor pressure. The batch reactor temperature was controlled by either steam or cooling water that could flow through coils that were mounted to the inside wall of the reactor. The contents of the batch reactor could be mixed by an agitator. And the batch reactor was also equipped with a ruptured disc with a burst pressure of 75 pounds per square inch gauge, or PSIG. And it had a pressure relief valve with a 75 PSIG set pressure. Design documents indicate that batch reactor 6 was a 2,500-gallon vessel. It was constructed of 316 stainless steel, and it had a maximum allowable working pressure of 75 PSIG and a maximum allowable working temperature of 355 degrees Fahrenheit. To produce the caramel coloring on the day of the incident, operators followed a batch instruction that detailed 1, the types and quantities of materials to add to batch reactor 6, 2, the material feed sequences, and 3, important process conditions such as temperature and pressure set points. The caramel coloring batch being prepared at the time of the incident included the following raw material ingredients. They included sugar, water, sodium hydroxide, and phosphoric acid. An anti-foam additive was also used to reduce the foaming during the batch operation. I'll now walk through the incident timeline that we were able to determine leading up to the incident. On November 12th, 2024, at 10:22 a.m., operators began the caramel coloring batch operation. They followed the batch instruction, and normal operations were observed during the first half of the batch production process. At 2:17 p.m., in accordance with the batch instruction, the operators set the batch reactor 6 pressure set point to 12 psig, and they set the temperature set point to 300 degrees Fahrenheit. To achieve this pressure and temperature, the programmable logic controller, or the PLC, automatically closed the vent valve that was at the top of batch reactor 6, which would allow the pressure inside the reactor to increase. Steam also flowed through the coils to increase the reactor temperature to the set point. After these adjustments were made, both the temperature and the pressure inside batch reactor 6 began to rise as expected. And then when the pressure reached the 12 psig set point, we can see that the vent valve automatically modulated as expected, and it maintained the pressure at 12 psig for approximately 16 minutes. At 2:39 p.m. is where things began to deviate, which is what we could see in the data. Sorry, we're back on the timeline slide. Go back. Back.
Give me 1 second here.
Yeah, it's called incident timeline. There we go. Yeah. Let's see. At 2:39 p.m. is when things we can see in the data began to deviate from what was planned. At 2:39 p.m., the batch reactor pressure began to exceed the 12 psig set point. The process data indicates that the vent valve was commanded to fully open at 2:40 p.m. And what this action would have done would be to help reduce the batch reactor pressure. But what we see is that the pressure continued to rise inside batch reactor 6 even after the valve was commanded to fully open. We found that the valve might not have actually opened, even though the data said it was open, and I will explain that a little bit later in this presentation. At 2:47 p.m., the batch reactor temperature also began to exceed its set point. The operators then observed these abnormal pressure and temperature increases, and cooling water was introduced to the coils at 2:49 p.m. in an effort to reduce the temperature inside the reactor. The temperature and pressure, however, continued to rise even after the cooling water system was activated. Process data indicates the pressure relief valve then opened at 2:54 p.m. And that was it had the 75 psig set point. And the pressure temporarily reduced before the pressure again began to rise. Both the temperature and the pressure continued to rise until batch reactor 6 catastrophically ruptured at 2:57 p.m. The maximum temperature that we can see in the data was 385 degrees Fahrenheit, which was 30 degrees above the maximum allowable working temperature of 355 degrees. The maximum pressure that we can see in the data was 237 PSIG, which was more than 3 times the maximum allowable working pressure of 75 PSIG. Next slide. As a result of the explosion, two of the Givaudan employees were fatally injured, and 3 additional employees were seriously injured. The 2 fatally injured employees, along with 4 additional workers, were all inside the control room at the time of the incident, and the control room is highlighted in yellow on this slide. Next slide, please. The facility was severely damaged by the explosion. Debris from the explosion was ejected outside the fence line and into the nearby neighborhood. Debris that was found in the neighborhood included large pieces of batch reactor 6, pipe fragments, instrumentation, valves, and building materials. Fragments of the exploded vessel flew as far as about 400 feet from the facility into the nearby neighborhood. Nearby homes and businesses also experienced shattered windows, property damage, and power outages as a result of the explosion. The local officials issued a shelter-in-place order for a 1-mile radius around the facility, and 2 elementary schools and 1 K-12 school in the nearby area were also ordered to shelter in place, and the dismissal at those schools was delayed. Here we're looking at a photo of the vent valve that appears to may not have been opened or when the data commanded it to. So after the incident, at the direction of the CSB, Givaudan inserted a borescope into piping that was connected to that recovered vent valve to identify the valve's position. The borescope photo is this central photo on the slide, and it shows that at the time of inspection, the vent valve is almost fully closed. The incident data shows that the valve had been commanded to fully open, and Givaudan had also specified that the vent valve actuator was to be configured to fail open, meaning that the valve should automatically open if the instrument air pressure to the actuator is lost. The CSB is going to further inspect this recovered vent valve and its attached actuator as part of the ongoing investigation. Givaudan has announced that it will not be rebuilding the caramel coloring manufacturing facility at its current location. And after the conclusion of the CSB's on-site efforts, Givaudan will complete the demolition of the site. The CSB is continuing to gather facts and analyze several key areas, including testing the raw materials to identify potential reactive hazards, analyzing the batch reactor relief system, reviewing process data and process conditions leading to the incident, further analyzing the recovered vent valve and the actuator, evaluating emergency response efforts, and analyzing the building design. This investigation is ongoing, and our complete findings, analyses, and recommendations will be detailed in the CSB's final investigation report. But you can find everything I discussed today in our published investigation update, which is on the CSB website. Thank you, and that concludes my presentation.
Well, Lauren, thank you very much for the presentation, and also I'd like to thank you and the team for the amount of work that's been accomplished since the November deployment to this incident. Our next series of 6 presentations are going to involve the incident report document, and I'm going to ask Dan Tolima, our senior chemical incident investigator, who heads up the accidental release reporting rule and the development of the incident reports, to proceed with the series of presentations. And Dan, please do introduce the members of your team when it comes to their turn to make their presentations. So Dan, please proceed.
Okay. Thank you, Executive Director Kleist. My name is Dan Tolima, and I will kick off the update on our accidental release program. This next slide, Steve. This screenshot is from the current version of the spreadsheet that should be posted on our website later today. We now have 497 accidental release events, which is about 8 events per month over the 61 months of this program. As you can see, serious injury remains the #1 consequence that triggers reporting, and more than half the reportable events involve at least one serious injury. Next slide. This graph shows the number of accidental release events monthly using a 3-month moving average. The downward trend we reported back in January ended, with 25 accidental release events being reported from January 15th through the end of February. Next slide. On March 12th, we published our second volume of incident reports, providing the public with more information from the accidental release reporting rule. Each incident report summarizes the accidental release event and provides a probable cause statement. We anticipate releasing a new volume of incident reports each quarter. Volume 2 covered 25 accidental release events in 14 states. Combined, these events resulted in 7 fatalities, 23 serious injuries, and more than $1 billion in property damage. Next, 5 investigators from our accidental release team will each review one of the serious events included in the second volume of incident reports. Eduardo Alvarez will review the fatal naphtha release and fire at the Marathon Refinery in Texas City, Texas. Laro Dolidze will discuss the piping failure and chemical release at the Tronox facility in Hamilton, Mississippi. Lisora Maldonado Pereira will cover the fatal explosion and fire at the W.S. Red Hancock facility in Canton, Mississippi. Zach Reagan will review the tank explosion and fire at the Tradeby facility in Bridgeport, Connecticut. And Owen Tripany will cover the fatal chemical release at the Daikin facility in Decatur, Alabama. That concludes my update. Up next is Investigator Eduardo Alvarez.
Thank you, Dan. And hello, everybody. My name is Eduardo Alvarez, and today I will be speaking about the fatal flammable naphtha release and fire at the Marathon Galveston Bay Refinery in Texas City, Texas, that occurred on May 15th, 2023. For this incident, the release formed a vapor cloud that quickly ignited and created a fire. The fire fatally injured 1 worker and resulted in $829 million in property damage. On the morning of the incident, 2 Marathon employees were completing an equipment oil change on an elevated platform above a pump that was supplying naphtha to downstream equipment. The pump's coupling failed, reducing outlet flow and causing high vibration that broke a small bore piping section, which released the flammable naphtha. Employee 1 was on the platform cleaning up the work area while Employee 2 was carrying a bucket of oil down the stairs from the platform. Employee 2 smelled the release hydrocarbon and saw what looked like a steam cloud. Within minutes of the release, the flammable vapor ignited. Employee 2 was able to exit the unit before the flammable naphtha ignited. Employee 1 was not able to escape from the elevated platform and was fatally injured by the fire. Marathon's investigation found that a pump inspection in June of 2022 had identified damage to the coupling of the pump, but did not recommend any repairs. During the release, the pump's motor continued to operate and spin the damaged coupling. The heat generated by the friction ignited some of the released naphtha, resulting in the fire. Additionally, the heat from the fire ruptured more piping sections and damaged other equipment in the surrounding area. Marathon also found that, according to the company's mechanical integrity program, vibration analysis should be performed every 2 months to predict pump failures, including coupling failures. The last vibration analysis test on the pump was completed in October of 2022, 7 months before the incident. During this incident, 102,000 pounds of naphtha and light hydrocarbons were accidentally released. The CSB determined that the probable cause of the accidental release was flammable naphtha was a pump coupling failure that created high vibration, which broke a section of small bore piping. With the pump's motor continuing to operate, the coupling failure created enough heat from friction to ignite the released naphtha and start a fire. Contributing to the incident was Marathon's mechanical integrity program, which did not perform the required vibration analysis on the pump and did not repair the damaged coupling after an inspection identified it. That concludes the Marathon Petroleum accidental release incident. Up next is Investigator Lotto.
Thank you, Investigator Eddie. And hello, everyone. My name is Laura Dolidze, and I've been with the CSB for 7 months. Today, I will be reviewing the toxic release at the Tronox facility in Hamilton, Mississippi that occurred on February 14th of 2024. Exposure to these toxic vapors seriously injured 2 Tronox employees. Before the incident, the 2 employees were performing maintenance on piping that had become clogged from accumulated solids. The piping connected a solid separator to a tank that contained water, cooling the solids that fell into it. During the maintenance, the separator sprayed liquid titanium tetrachloride to control its temperature. Additionally, the valves on the piping were left open, which allowed titanium tetrachloride to accumulate in the plug piping. The clog dislodged during the maintenance, causing excess solids and titanium tetrachloride to fall into the tank. The titanium tetrachloride reacted with the water in the tank, creating hydrogen chloride vapors and increasing the pressure within. The pressure relief device's inlet piping on the tank was clogged with solids and did not activate. Consequently, the built-up pressure broke separate piping directly under the 2 employees, releasing and exposing them to a mixture of titanium tetrachloride and hydrogen chloride vapors. Neither operator was wearing respiratory protection to protect them from the release, as it was not required for the maintenance work. The CSB determined that the probable cause of the incident was a reaction between titanium tetrachloride and water, which generated hydrogen chloride vapors. High-pressure conditions developed in the system and broke the piping connected to the water tank, releasing toxic vapor to the surrounding air, which seriously injured the 2 Tronox employees. The water tank's pressure relief device did not activate because its inlet piping was plugged with solids, contributing to the incident. Not wearing respiratory protection during the maintenance work contributed to the severity of the incident. That concludes the Tronox accidental release incident. Up next is Investigator Lisara.
Thank you, Lalo. Good afternoon. I'm Lisaura Maldonado Pereira, and I'll be talking about the explosion that occurred at WS Red Hancock. On July 29, 2022, a crude oil separation tank exploded at the Red Hancock facility in Canton, Mississippi. The explosion and fire fatally injured 1 employee and seriously injured 5 other employees. Red Hancock separates crude oil condensate from salt water through a series of 4 tanks, then pumps the waste into a saltwater disposal well. At the time of the incident, Red Hancock was replacing 2 of the separation tanks. While most of the liquid had been removed from the tanks before the replacement work began, some salt water, hydrocarbons, and air remained. At the time of the incident, 7 employees were completing the tank replacement work, which included installing a walkway between the tanks and finishing piping connections between them. While welding piping between the 2 middle tanks, one of the employees opened a valve to an older tank that contained crude oil condensate material. This likely allowed some hydrocarbon vapors into the piping being welded. The flammable vapor ignited, and the flames traveled back into the tank, resulting in an explosion and fire that ejected the top of the tank. In addition, the blast launched another tank approximately 80 feet away. As a result of explosion and fire, 6 of the employees were transported and admitted to the hospital for their burns. 1 of the employees died at the hospital 6 days later. No work permits were written for the welding work to replace the tanks. The tanks involved in the incident had not been thoroughly cleaned, which allowed flammable material to remain near the welding activity. The CSB determined that the probable cause of the incident was the presence of flammable vapors near a welding activity being performed. Not thoroughly draining, cleaning, and purging the tanks to remove the flammable material before starting construction contributed to the incident. This concludes Red Hancock's update. Next is Investigator Zach.
Thank you, Lisara. Good afternoon. My name is Zach Reagan, and I will discuss the explosion that occurred at Trade Environmental Services. On December 29th, 2023, a storage tank exploded, creating a fire at the Trade facility in Bridgeport, Connecticut. The explosion and fire seriously injured 1 contractor and caused $5.8 million in property damages. Trade to Be workers finished transferring 4,000 gallons of organic material into a 10,000 gallon epoxy lined steel storage tank from another vessel at the facility. The transferred materials included naphthalene, methylene chloride, tetrahydrofuran, toluene, xylenes, and trimethylbenzene. The transfer of the organic material was not tested for chemical compatibility and resulted in the agitation of 6,000 gallons of sludge already inside the storage tank. The sludge contained hydrogen peroxide, organic peroxides, and metal ions including cobalt, iron, nickel, and chromium. Agitating this material likely started a decomposition reaction between the organic material and peroxide components in the presence of metals. This reaction produced flammable vapor, oxygen, and heat, and at 1:45 p.m., the flammable vapor within this tank auto-ignited from the heat generated by the reaction, and the storage tank exploded, causing a fire. The explosion and fire seriously injured one truck driver who was at the facility to make a chemical delivery to a different tank. After this incident, Trade to Be started to require compatibility testing before any material transfer and to clean the storage tanks at the facility routinely. The CSB determined that the probable cause was mixing reactive chemicals within a storage tank, which created flammable vapors, oxygen, and heat. The heat from this reaction ignited the flammable vapor in the tank, resulting in the explosion. Trade to Be could have prevented this incident had they confirmed chemical compatibility before transferring material into the storage tank. This concludes the Trade to Be accidental release event. Thank you, and next to speak is Investigator Owen Tripany.
Thank you, Zach. Good afternoon. I'm Owen Tripany, and I'll be talking about the toxic chemical release that occurred at Daikin America Incorporated, or Daikin. On July 2nd, 2021, approximately 700 pounds of vapors containing chlorodifluoromethane, or R22, and perfluoroisobutene, or PFIB, were accidentally released at the Daikin facility in Decatur, Alabama. Exposure to the toxic vapors fatally injured 2 Daikin operators and seriously injured another Daikin operator. Daikin was returning a drying tower to service after it had been offline for maintenance. After completing the maintenance, the tower contained air which needed to be removed before startup. Daikin's procedure to remove air included filling the column with nitrogen, then purging the nitrogen in the column with R22. The purged vapors were released into the atmosphere from an open valve about 6 feet above the ground. The valve was aimed vertically downward, resulted in the vapors being released toward the working area. Daikin's procedure did not specify where the R22 used in the purge should come from. Therefore, the operators took the R22 from another process vessel, which contained toxic chemicals like PFIB. As Daikin's operators were purging the tower, R22 and PFIB were released into the ambient air from the open valve, exposing the 3 operators to the toxic vapors. The operators did not immediately report any symptoms from the exposure and went home after their shifts were completed. Approximately 2 days later, 2 of the operators became ill and were admitted to the hospital. The next day, the 3rd operator was hospitalized. 2 of the operators succumbed to their respiratory injuries, one on August 10th, 2021, and the second on September 28th, 2021. After the incident, Daikin updated its procedures to warn operators toxic vapors may be present and require that its operators wear supplied air respirators during the purging process. Additionally, the company now sends the purge vapors to an incinerator and requires using only high-purity, non-toxic R22. The CSB determined that the toxic PFIB vapors were likely released with R22, which was purged from equipment into the ambient air to remove nitrogen. Had Daikin ensured that the release of PFIB was avoided or discharged to a safe location, the incident could have been prevented. This concludes the accidental release team update. Thank you. Back to Executive Director Kleist.
Well, thanks you to the entire incident reporting team for your presentations this afternoon, as well as your effort to produce the 2nd volume of our incident report document. This is a very meaningful document to the industry. I've heard very positive feedback on this new additional outreach opportunity that we have for sharing our very important message with the industry. So I thank you all for your work in producing this document. We're going to shift now from investigations to another critical element of the agency's operation, and this would be the Office of Recommendations. We have two presentations scheduled. Both will be done by Adam Henson. So Adam, please proceed, and you can move from the first to your second presentation.
Thank you, Executive Director Kleist. Good afternoon, everyone. My name is Adam Henson from the Office of Recommendations. Today I'll be discussing the BP Texas City incident with you, as well as giving an update on some recommendations actions from the previous quarter. Next slide, please. It's been said that there are incidents that are so iconic and impactful that they must be part of the basic knowledge of everyone who works in the chemical industry. Though we may not be able to remember every detail from these incidents, they indeed should serve as a reminder of the vulnerability all processes face and call everyone to use all of their professionalism to prevent such incidents. One such incident is the BP Texas City explosion and fire that occurred in Texas City, Texas on March 23rd, 2025. As previously mentioned, this incident resulted in 15 fatalities, 180 injuries, significant community impact, and greater than $1.5 billion in loss. In a moment, we will show an animation excerpted from the CSB's 2020 video on the BP Texas City incident to demonstrate the magnitude of the explosion and explain some of the loss in greater detail. Steve, when you're ready.
As flammable hydrocarbons overfilled the blowdown drum, operators nearby saw a geyser of liquid and vapor erupt from the top of the stack. The equivalent of nearly a tanker truck full of hot gasoline fell to the ground and began forming a huge flammable vapor cloud. The vapor cloud expanded in just 90 seconds, engulfing the unit and the nearby trailers full of workers. About 25 feet from the base of the blowdown drum, two workers were parked in a pickup truck with the engine idling. As flammable vapor entered the air intake, the diesel engine began to race. The two workers fled, unable to shut off the engine. Moments later, witnesses saw the truck backfire and ignite the vapor cloud. Powerful explosions swept through the area. The blast pressure wave accelerated through the ISOM unit, causing heavy destruction and igniting fires. The workers inside the trailers were right in the path of the explosions. The fires continued to burn for hours. 12 of the 20 occupants of the double-wide trailer were killed, along with 3 workers in a trailer nearby. 180 workers were injured, many with serious burns, fractures, or other traumatic injuries. The wood and metal frame trailers were blown apart by the blasts. Firefighters struggled to rescue the injured and recover the victims. 50 large chemical storage tanks were damaged, and the ISOM unit remained shut down for more than 2 years. The disaster at BP Texas City was the most serious refinery accident ever investigated by the CSB.
So it's one thing to talk about an explosion and a fire and to talk about 15 people being dead. But one thing I especially appreciate about the CSB is the development of these animations that really bring to life the circumstances of these tragic events. Some of the lessons learned from the BP Texas City incident regarded facility siting. As mentioned in the video, all of the people who died were inside of trailers that were installed temporarily to facilitate a turnaround going on at the facility. Had those trailers been sited elsewhere on the facility further away from the active unit, the consequences of this incident would have been severely less. Another lesson learned regards safer alternatives. The pressure relieving system of this facility was set to discharge to atmosphere, which is common in industry and can be achieved safely, but there are safer alternatives. Had the material discharged from the process at BP Texas City been disposed of through flare or recirculated through the process in a manner that was safe, this incident could have been prevented entirely. Standardized indicators. At the time of BP Texas City incident, many facilities on on occupational safety and health type metrics such as total recordable incident rate. And while these metrics can be important and should be tracked and verified, they are insufficient to determine the level of risk experienced by a facility. It's well known that the BP America refinery in Texas City had an exemplary occupational safety and health rate, but unfortunately that did not stop this terrible tragedy. Another factor involved in the incident was worker fatigue. The employees on shift at this refinery, many of them had been on a 12-hour shift for in excess of 30 days at the time of this incident. For a facility to operate safely, workers must be able to bring their best to bear, and unfortunately fatigue is something that has to be managed. Another observation made by the investigators at the time is that BP America Texas City had an ineffective safety culture organizationally. Though they continued to have incidents and accidents, corporate BP America diverted resources away from the facility, which negatively affected both process safety and mechanical integrity specifically. And finally, as BP made the decisions to divert these resources from the facility, including staff layoffs, they did not contemplate the effect that those changes would have on process safety. And the next slide will discuss the recommendations that were issued from the investigation. Next slide, please. In total, there were 26 recommendations issued, 25 of which have been successfully closed. 3 of the recommendations were issued to the Occupational Safety and Health Administration. One of those recommendations was an urgent recommendation for OSHA to inspect refineries under an emphasis program. Another recommendation that was issued called upon OSHA in those inspections to look for the issues that were specifically cited in the BP Texas City incident. Those 2 recommendations were successfully closed. The third recommendation called upon OSHA to make clear in their process safety management standard that organizational changes must be evaluated under a management of change paradigm. This recommendation, though issued nearly 20 years ago, remains open to this day. 7 recommendations were issued to industry groups such as the American Petroleum Institute and the Center for Chemical Process Safety. Significant consensus standards were produced by the American Petroleum Institute, covering topics such as fatigue, metrics, and the location of temporary structures and trailers. The Center for Chemical Process Safety, for their end, were given a recommendation to create guidance on organizational management of change, which they did successfully. BP America Corporate was given one urgent recommendation to commission a panel to investigate the incident independently, which resulted in what was known as the Baker Report. Other recommendations issued to corporate BP were for them to improve organizational culture by installing leadership with safety roles and to provide resources for their facilities. The facility was given 8 recommendations. They satisfactorily implemented all recommendations. And finally, the United Steelworkers, including the local responsible for Texas City, was given 3 recommendations. And in our recommendations to them, we charged them with assisting both BP facility and the American Petroleum Institute in carrying out their recommendations. The United Steelworkers, they held up their end of the recommendations and provided valuable resources to those efforts, for which we would truly appreciate. This is the 20th anniversary investigation digest that was mentioned during the board's remarks. We issued this publication last month in commemoration of the 20th anniversary of the incident. It's a very succinct and powerful document that really does capture the lessons learned. And it ends with an appendix that explains what all the recommendations were and what their current status are. I encourage you to seek out this document on the CSB website on either the BP Texas City investigation page or on the newly launched advocacy products page. Next slide, please. We'll conclude our discussion of the BP Texas City incident with a quote from former CSB Chairman John Breslin, which was made on the 5th anniversary of this incident. Former Chairman Breslin observed or opined or asked, "When will we know whether the tragedy of 2005 has resulted in greater safety at BP and other company refineries? Only when we can look back over the passing of a significant number of years without major accidents, deaths, or injuries." Unfortunately, I can't say back, please. Unfortunately, I'm afraid we can't claim victory just yet. So I have to call upon myself and everyone else on the call to fulfill the remainder of former Chairperson Breslin's quote, where he asked us to commit ourselves to find and fix even the smallest hazards in the hopes of preventing these low probability, high consequence events. This concludes our discussion of the BP Texas City incident. Next, I'd like to call your attention to some recent successes we've had in making some actions over in the recommendations department in the previous quarter. We'll discuss the recommendation we gave to the Center for Chemical Process Safety in our Walker investigation, and we'll discuss the recommendations we've issued to the National Fire Protection Association. Next slide, please. For those unfamiliar, the Walker polysilicon chemical release occurred in Tennessee on November 13th, 2020, where 2 work groups comprised of 7 people performing separate activities were on the 5th story of an equipment maintenance platform. During their work, a graphite heat exchanger cracked, releasing gaseous hydrogen chloride. 3 of the employees were protected with personal protective equipment because of the nature of their work. Other employees were not wearing personal protective equipment because of the nature of their work. Upon the release, the employees who were not protected by personal protective equipment faced the impossible choice of being burnt with chemicals or to climb over the rail to attempt to flee the cloud. The 3 employees who climbed over the rail, unfortunately, all fell. 1 employee died, and the other 2 employees were significantly injured. In the CSB's investigation, the CSB uncovered that there was no comprehensive resource on SIMOPS for the chemical industry to follow. This led us to issue a recommendation to the Center for Chemical Process Safety to develop and publish a safe work practice on SIMOPS. Next slide, please. The Center for Chemical Process Safety got right on this task. They involved us in the development of it, which we truly appreciate, and they published their final product to their website on February the 4th, 2025. This safe work practice, built on existing CCPS guidance on SIMOPS, addresses the SIMOPS all throughout its life cycle and discusses several incidents involving SIMOPS to illustrate the concepts of the publication. We were happy to close this recommendation acceptable action. Next slide, please. The next incident we'll discuss was the Diddy Milling Company explosion and fire, which happened in Wisconsin on May 31st, 2017. This explosion occurred at a corn milling facility, and the explosion originated in the milling equipment. The result of the incident was 5 fatalities, 14 serious injuries, and the near total destruction of the facility. At the time of the incident, only 19 people were working at this facility, and all 19 were injured, if that's enough to demonstrate the significance of this incident. Amongst other recommendations, the CSB issued a recommendation to the National Fire Protection Association after observing that the combustible dust standards applicable to food processing facilities such as Didion were somewhat lax with regards to dust hazard analysis, management of change, and incident investigations, as opposed to their counterparts in the wood handling and metal handling industries. Next slide, please. Our recommendation happened to coincide with an NFP effort to consolidate all of their standards on combustible dust into one standard, which is known as NFPA 660. NFPA published their first edition of NFPA 660 in December of 2024. This first edition addresses the recommendation and exceeds the requirement of the recommendation based on its contents. Notable accomplishments in this publication are improvements in content for informational resources on management of change, dust hazards analysis, and incident investigation. And also, they have added a subject on topic of self-heating hazards and chemical reactivity hazards that could have possibly contributed to preventing incidents the CSB has investigated, such as Biolab Lake Charles, and the Optima Bell incident in West Virginia. We were thrilled to go ahead and close this recommendation, exceeds recommended action. We really appreciate the effort of NFPA to close this item out. Next slide, please. The Didion milling facility itself was the recipient of 9 recommendations as a result of this investigation, which are listed there below. During our investigation, it was noted that Didion did not have a comprehensive to manage dust hazards at their facility. Their pneumatic conveyance system was installed in a manner which was inappropriate and also was not maintained to keep appropriate velocities. The DHAs that the facility had performed could be described as limited. They had not addressed hazards of venting explosions within their building. Many of their records were lost in the case of this explosion. We asked them to keep electronic records. There were PPE issues. There were emergency response procedure issues. There was a lack of deflagration protection. And overall, we determined in the investigation that there was a lack of safety leadership at the facility. I call your attention to the graphic to the left. If you see the buildings in the areas that are dotted with red dots, these are the buildings that were completely destroyed by the incident, while the buildings that were dotted with yellow dots were those that were damaged by it. More critically, if you see the circles with the red or the yellow circles with the red outlines, these are the locations of the employees that were killed by this incident. And the pentagons are the ones that were injured. As you can see, if you were almost anywhere on this property during this incident, you were hurt by this incident. Next slide, please. Unfortunately, we have not been able to secure the cooperation of the Didion Milling facility in implementing these recommendations. They did provide a response in the summer of last year, which was primarily based on an agreement they had reached with OSHA to settle out their enforcement citations. We communicated back to Didion that was wholly inappropriate and did not address the specifics of our recommendation. We've been trying to encourage them to answer back, and unfortunately, we've pretty much lost communication with them. And while we are hoping to reestablish that communication, in the meantime, Board Order 22, which governs our recommendations program, requires that we assign them a status of open unacceptable response. Next slide, please. And then finally, we'd like to acknowledge that all of the recommendations from the Watson Grinding Fatal Explosion and Fire were successfully closed last quarter. The Watson Grinding Fatal Explosion and Fire, which will be discussed in the video following this presentation, was responsible for 3 fatal injuries, including 1 person who was off-site, 2 serious injuries of other employees, and the damage to hundreds of businesses and homes. Both of the recommendations that were issued in Watson were closed acceptable action, meaning that the recipient took the action as basically specifically directed by the board. We'd like to commend the Compressed Gas Association and Mathic and Trigas for their cooperation in bringing these recommendations to a close. This concludes the presentation from the Office of Recommendations. Thank you.
Adam, thank you for the briefing on the recommendations closeout, as well as the BP Texas City document. Want to thank you and the other members of the team, Chuck Barbie and Amanda Johnson, for your collective hard work in completing what is the rest of our cycle of when we launch and deploy a team to an incident, the very important recommendations that are issued as a result of the investigation. That's only one part of a complicated process that ends with a presentation similar to what Adam did here, where we can report out on the status of our important recommendations that really drive chemical safety change within the industry. I'd also like to recognize Amanda Johnson for her work in the BP Texas City report that Adam spoke to. We very much appreciate your work in making this happen. With the completion of that presentation, I'd like to turn the presentation back over to Chairperson Owens. Thank you.
Well, thank you, Steve, and thanks to all the terrific team members who gave those presentations. I'd just like to make a couple of comments before we go to the viewing of the Watson Grinding video. First, with regard to the presentations that you all heard about our chemical incident reports that were published most recently in Volume 2 of those reports. As Sylvia Johnson said during her opening comments, these are all incidents to which we did not have the ability to deploy, partly because of the tremendous backlog the agency had experienced that had built up over so many years, but also because of the limited resources that the CSB has. You can see the dates in some of those incidents and all that, but as a result of our being able to completely eliminate the backlog, and now we have a number of current ongoing investigations, which I mentioned in my remarks, we're in a better position to deploy to incidents and issue timely investigation reports. But there are a lot of incidents that occur on a weekly basis. As Dan Tolima indicated during his remarks in the graph that he shows, we get reports every week about serious chemical incidents around the country. And those are just, I'll use the word just, the incidents that meet the reporting criteria that exist in our accidental release reporting rule. There are lots of other incidents that are occurring out there that aren't reported to us because they don't meet that criteria. So we have a very big job, and we try to do it as best as we can with our limited number of resources and the limited employees we have. And as you can see, the terrific staff we have been doing a great job, not only of conducting current investigations, but of summarizing the reports that we receive under the release reporting rule. And now we're providing that information to the public. And as Director Kleiss said, It's already become a very useful tool for the chemical industry itself to have that kind of information, to see the types of incidents that are occurring and reoccurring across this country, and helping them to take the kind of action, hopefully, that'll prevent future incidents like those from occurring. Just one other quick comment with regard to Adam Hansen's presentation on the recommendations that we've adopted status changes for. In the history of the CSB, we've talked about this a bit in our January meeting, but in the history of the CSB, we've issued over 1,000 recommendations, and 1,008 so far, to be exact, and 87% of those recommendations have been closed by the CSB over the years. Only 13% of the recommendations remain open. Excuse me, and a great many of those are investigations or recommendations rather that came from those 17 backlogged investigation reports that we issued in recent years, as well as most recently the BP Husky and now the Marathon Martinez reports that we've issued over the last year. But none of that could have been done without the hard work of our recommendations team and other critical team members here at the CSB, continuing to outreach to the entities, whether it's the companies or trade associations or standard setting groups or other governmental entities, to close those recommendations and to get them to take the action that we've recommended be taken to help protect workers, communities, and the environment from these catastrophic chemical incidents that are occurring in our country on a regular basis. Sometimes it doesn't always work. Sometimes we do have to close recommendations, even though they haven't been successfully completed. But we do stay at it, as Adam indicated, with particular regard to the Didion recommendations. We're going to continue to push hard on those and do everything we can to get them implemented. We are a non-regulatory agency and we don't have enforcement authority, but our goal is to issue recommendations that are implementable and will make a difference out there. And we believe that's what this agency has done very successfully in its history, and will continue to do so as we move forward. I'd now like to tee up the Watson grinding investigation. As we've mentioned a couple of times before, this video that was released on that investigation was issued on February 5th. So just right at about 2 months ago. The Watson grinding incident in itself, as you've heard, was a fatal polypropylene release, an explosion at the Watson grinding facility near Houston, Texas. 3 people died in that, 2 workers and 1 person who was in their home who died as a result of the blast. And it damaged hundreds of nearby businesses and homes in the area. So with that, Steve Hamrick, if you will tee up the video and we'll watch that.
January 24th, 2020, the Watson Grinding and Manufacturing Company in Houston, Texas. An accidental release of propylene accumulated inside a building and ignited, causing a massive explosion. The explosion fatally injured 2 workers and a member of the public. Hundreds of nearby structures were damaged, including homes and several businesses.
Our investigation found that Watson Grinding did not have an effective system in place to address potential hazards in its propylene process and did not have a mechanical integrity program or written operating procedures. This tragic incident was made even worse due to the lack of emergency response training for employees at the facility. As a result, 3 lives were lost and the surrounding community was put at great risk.
The Watson Grinding and Manufacturing Company was comprised of several production buildings, as well as a company gym. It was located in a densely populated area of Houston, Texas. The company specialized in machining and grinding services, as well as applying high-performance coatings, particularly high-velocity oxygen fuel, or HVOF, coating. HVOF coating extends the service life of metal parts used in highly corrosive environments, such as specialized chemical, mining, and aerospace equipment. One of the buildings at the Watson grinding facility was known as the coating building. Inside were 8 coating booths, 6 of which were used for HVOF coating. The process of HVOF coating involved propylene, an extremely flammable hydrocarbon gas. Propylene was routed into the coating building through piping connected to an outside storage tank, which was located in a separate area of the facility. On the day prior to the incident, operators shut down the individual coating booths, and the coating supervisor closed and locked the coating building. But the CSB found that there was no established policy or procedure for isolating the storage tank at the end of a workday. Neither the manual shutoff nor the remote shutoff valves located at the propylene storage tank were closed before the workers left for the night. At some point overnight, a degraded and poorly crimped rubber hose, which connected to the propylene piping, disconnected from its fitting inside one of the coating booths. With the shutoff valves to the propylene storage tank open, flammable propylene was able to flow freely from the tank through the piping and into the coating booth. The coating building was equipped with an automatic gas detection system that included wall-mounted gas detectors inside each booth. The automatic gas detection system was meant to alert operators to a leak, as well as trigger remote shutoff valves to stop the flow of propylene. But the CSB found that several years prior, Watson Grinding disconnected the booth's gas detectors from their computer control system. This rendered the automated gas detection shutoff system useless. As a result, there was nothing in place to stop the flammable propylene from accumulating to dangerous levels inside the coating building. Around 3:30 a.m., 2 employees arrived on site to exercise at the gym prior to their workday. One employee could smell what he believed to be propylene outside of the building and insisted that the 2 of them investigate the odor. Just outside the coating building, the employees could smell a strong propylene odor and hear a loud hissing noise coming from inside the building. They suspected there was a leak inside. At around 4 a.m., they returned to the gym, where they texted the coating supervisor and called the plant manager to alert them of the suspected leak. Neither the coating supervisor nor the plant manager advised the 2 employees to evacuate the area. Instead, one of the employees decided to exit the gym to investigate the leak further. At 4:19 a.m., the coating supervisor texted all coating booth operators, alerting them to a potential leak and telling them not to start up yet. But shortly after 4:23 a.m., a coating booth operator in possession of a key to the coating building arrived at work to open it up. As he entered the building and turned on the lights, the accumulated gas ignited, causing a massive explosion. The coating booth operator and the worker who first noticed the leak were both fatally injured by the blast. A nearby resident died 2 weeks later due to injuries sustained at his house caused by the large explosion. The explosion affected over 450 neighboring structures, including homes and businesses, with some sustaining major damage. The explosion also caused significant damage to Watson Grinding, and the company, which employed 130 people, eventually filed for bankruptcy and ultimately closed. The Chemical Safety Board launched an investigation and found 2 safety issues contributed to the deadly incident. They are process safety management and emergency preparedness. The first safety issue is process safety management. The CSB determined that neither OSHA's Process Safety Management Standard nor the EPA's Risk Management Plan rule applied at Watson Grinding. Therefore, the company was not required to implement a process safety management system for the propylene coating process. But the CSB believes that several elements of an effective process safety management system, if implemented, could have helped prevent this incident. Those elements include process safety information, process hazard analysis, management of change, mechanical integrity, and operating procedures. For example, Watson Grinding did not maintain important process safety information for the automated gas detection system installed inside the coating booths. This led to this critical safety system not functioning on the day of the incident. The wall-mounted gas detectors inside the coating booths were originally configured to transmit a signal to a computer control system if a dangerous amount of flammable gas was detected. The computer control system was then to trigger alarms to notify employees of a release, automatically start up the booth's exhaust fan to help remove the flammable gas, automatically close a remote shutoff valve located inside the coating booth, and automatically close a remote shutoff valve at the propylene storage tank. But years prior to the incident, the gas detectors had been disconnected from the computer control system. Gas sensor calibration contractors visited the coating building in 2013, 2016, and 2019 and raised concerns in writing about the disconnected automated gas detection system. And the CSB learned that Watson Grinding management also had a discussion just 2 weeks prior to the incident about how the booth's gas detectors were disconnected and needed to be fixed. But no action was taken, and this critical safety system was not functional on the day of the leak.
We found that Watson Grinding did not maintain engineering drawings and additional documentation on the system, did not maintain the automated gas detection system in working order, and did not train its employees to use or maintain the system effectively. This critical information could have helped keep the automated gas detection system working, which could have prevented this incident.
The CSB also found that Watson Grinding did not perform a hazard analysis on its propylene process to identify the hazards of a propylene leak and consider the critical safeguards necessary to control those hazards.
A hazard analysis should have identified that the gas detection system could no longer respond automatically to an identified propylene release. Action items to restore this critical system's functionality should have been promptly developed and implemented.
Additionally, the CSB found that the hose that disconnected and led to the propylene leak was a rubber welding hose that replaced a more robust copper tubing connection. The less expensive rubber hose is not recommended for propylene service because the oils in the propylene fuel gas can cause the hose to form cracks and lose pliability. But the CSB could not identify documentation showing that Watson Grinding performed a management of change review to identify the potential hazards associated with changing from the copper tubing to the rubber hose. Further, the CSB found that Watson Grinding lacked a robust mechanical integrity program. Such a program would have ensured a system was in place to guarantee inspection, testing, and preventive maintenance of the automated gas detection system, which would have kept the system in working order. And finally, the CSB found that Watson Grinding lacked effective operating procedures, such as a written coating system shutdown procedure that called for closing at least one of the shutoff valves at the propylene storage tank at the end of each workday.
Companies have a duty to ensure the safety of workers at their facilities and protect surrounding communities and the environment, regardless of whether they're required by regulation to apply a process safety management system. This tragic incident could have been prevented if Watson Grinding had developed such a system for its coating process.
As a result, the CSB made a recommendation to the Compressed Gas Association to urge member companies that handle hazardous chemicals to share information with their customers about the safety issues described in the CSB's Watson Grinding report and why their customers should develop and implement effective process safety management systems. The second safety issue found by the CSB at Watson Grinding is emergency preparedness. The CSB found that Watson Grinding had a written emergency response plan in place at the time of the incident that identified propylene as a significant fire hazard. However, the plan did not address any additional hazards of propylene or discuss how to respond to a leak or suspected leak. Watson Grinding also did not formally train its workers to recognize or respond properly to a propylene gas release. Therefore, on the day of the incident, workers did not evacuate the area after suspecting a propylene leak, did not prevent others from entering the area, and did not contact emergency responders for help.
Facilities that handle flammable gases or other hazardous materials should ensure that there is a comprehensive written emergency response plan that adequately addresses all actions to be taken in the event of a chemical release. Workers must be trained on the plan, and periodic drills should be conducted to ensure the plan can be effectively implemented.
This deadly incident could have been prevented if Watson Grinding had implemented a process safety management system to address the hazards of its coating operation. And even if a leak still had taken place, an emergency response plan could have prevented the tragic loss of life that occurred. We urge companies to develop and implement effective process safety management systems and emergency response plans so that something like this never happens again. Thank you for watching this CSB safety video.
For more information, visit csb.gov.
Hi, we are going to go ahead and move to the public comment section of our meeting. If you have a comment, please use the raise hand feature on the bottom of the Zoom window, and I will ask you to unmute. I can't unmute you, so you need to go ahead and unmute yourself and make a short public comment if possible, so we can meet our time frame. Please keep it to 2 minutes. Do we have any comments?
Hillary, while we're waiting for people to raise your hand, I know it always takes a little bit of time for folks to get focused here. If you do have a comment, in addition to stating your name, if you could also please state the organization, if any, that you're either associated with or work for, that would be helpful for us for our information.
We'll get no hand here.
I don't see any hands. If you want to submit written comments, you can email public@csb.gov. We'll give you 1 more minute. Oh, I see 2 hands.
Wow.
Sabrina Curley, please go ahead with your public comment.
Hi there, Sabrina Curley. Excited to listen to the public meeting that was just held. I'm a recent graduate of Michigan State University, where I've done work in both polymer industry and academia, but also working with EHS and safety at my university. And I want to just give public comment, like thanking the CSB for what they do, and that I was able to use the report that was generated based on lab safety hazard in academic environment for assisting the safety like regulations and updates to our policy at Michigan State. So thank you.
Well, thank you, Sabrina. It's always good to hear that the information we put out has been useful. I'll also say that one of our investigators is a Michigan State grad. So it's good to know that we're having impact on the community there. So thank you again for your comments.
We have another comment from Tracy Purdom. Tracy?
Can you hear me?
Yes, we can hear you. Please go ahead.
Alrighty. Tracy Purdom with Chemical Processing Magazine, and I did want to also comment and thank you for all the great work that you do at the CSB. We highlight your work often and talk about the lessons learned for our readers to help them get home safely after each and every shift. And the videos are just extremely useful as well to understand what's going on in the visualization, and bravo.
Thank you.
Well, Tracy, thank you for that. You guys do great work at the Chemical Processing Magazine there, and we follow it closely. So we appreciate you helping us get our safety message out as well. I will say, since you mentioned the videos, that the watch and grinding video, which we just showed, has been public for right at 2 months now. It was released rather on February 25th. So right at 2 months, and it's already received over 446,000 views. For folks who aren't familiar with our safety video program, you can find our videos both on the CSB website, but also on our YouTube page. If you just search Google, whatever search engine you use, search CSB and YouTube together, it'll pop up. It, as mentioned, is a very highly successful effort in terms of having an impact on the industry, and also helping the public at large understand what's happening with chemical facilities. To date, the CSB has issued almost 100 safety videos that have been posted to the YouTube page, and we have more than 372,000 subscribers to that page, which is pretty remarkable when you think about it, especially for a government agency. And so for the folks on this call, if you are a subscriber, if you're one of the 372,000 who are a subscriber, we thank you for that. If you're not already a subscriber, you can go to our YouTube page and please sign up, because we push out information all the time through that page when we release a video, and we're glad that they're of use to folks. So.
I do not see any more comments. Again, you can email your comments to public@csb.gov if you weren't able to make a comment, but I believe that wraps up our public comment session.
Well, great. Well, thank you. One last thing I'll say, and then I'll turn it over to Sylvia and Kathy for their closing remarks. Well, actually, two things I'll say. One is just to remind everybody that our next public meeting is in July, on July 24th, also at 2 p.m. Eastern time. So we look forward to seeing everyone there. But also there was a reference in Adam Henson's presentation to former chairperson John Breslin, who is often a viewer on these calls. I don't know if John is on the call with us today, but the CSB likes to quote John Breslin, and we like to remember the work that he did on the board, because he made a huge difference in the operations of this agency in its history. So we just want to thank him again for his service on the CSB. If he's listening today, if not, if anyone knows him, tell him we said thank you and hello. So, and with that, I'll turn it to Sylvia and then Kathy, and then I'll wrap it up for us.
Well, thank you, Steve, and thank you everyone for sticking with us today. We went, it's almost 4 o'clock Eastern, but we had a lot of material to cover, and you heard a lot about what the CSB has done. You've heard a lot of data and statistics on the work that we've done in the course of not only the history of the agency over the last 20 plus almost 30 years, but also over the last almost 3 years. And we've made a lot of progress. I really believe that CSB has made a huge difference in the lives of workers, communities, and the environment. And although we've done a lot and we have a lot of successes to point to, we recognize that we still have a lot of work remaining. And for everybody who's on this call, whether you're from industry or labor, or you're with the CSB, or any other entity, we can't do this work without your help. And we appreciate the collaboration that we have with the various entities that are on today's call, and we thank you for that. And We will continue the work of this great agency and continue to do what we need to do to move the agency forward and continue to do what we need to protect workers in the chemical industry as well as these facilities, because when these facilities blow up, it's not good for anybody. And so with that, I would say, again, thank you all for coming. Thank you again to the tremendous work of the team here at the CSB, and hope to see you all in July. Thank you.
Thank you, Dr. Johnson. And thanks everybody for continuing to listen. I know that we've shared a lot of information today, and it underscores the fact that CSB investigations involve literally thousands of hours of work by expert staff members. Most of whom are chemical engineers, some have a variety of degrees, but the CSB brings tremendous expertise to both investigations and recommendations. And you also heard from Adam that the recommendations process itself can take thousands of hours of work and in fact persist for years. Because as Steve Owens mentioned, the CSB is a non-regulatory agency. And so what we offer is the insight of our recommendations, the insight of our analysis, and the power of dialogue to help us come together as a national team to really improve safety, so that we can protect workers, protect communities, protect the environment, and indeed protect these facilities. So when we talk about how the CSB has an opportunity to bring forth learning about cross-cutting hazards, we also see cross-cutting consequences, and that was underscored today, where the consequences of these incidents are paid in lives lost, people very seriously injured, often with life-changing injury, some of those injuries happening in their homes across the street from these incidents, with property destroyed at nearby businesses, homes, and the plant. And in many cases, and we discussed several of those today, plants that closed as a result of these incidents, which means a loss of industrial capacity, a loss of jobs, a loss of economic opportunity. And so our goal is to bring forth this learning and make recommendations so that we can continue to improve and be able to carry out this work safely that is vital to America and indeed vital to the world. So I'd like to thank everybody who's involved in chemical process safety and each and every one of the employees at the CSB. We've only been able to hear from a small segment of CSB employees today, but the role of every person on our very small staff is absolutely essential to be able to carry out this important work and to promote safety and our economic competitiveness and opportunity. So thank you all for your contributions to safety. And with that, back to you, Chairman Owens.
Well, great. Thank you, Sylvia, and thank you, Kathy. And thank all of you once again for participating on this call with us and viewing this meeting. We look forward to seeing you all in July. So with that, we'll be adjourned. So thank you all.